compounds. So a little bit of a review. In our previous unit, we learned about different types of elements, right? We have metals that are typically on the left side of the periodic table. So things like lithium, calcium, beryllium, those are examples. And then we've also learned about nonmetals. Elements like carbon or fluorine or chlorine or bromine. And they have different properties and they combine in different ways. Now, those elements can combine to form compounds. And we're just going to do a little bit of review and reminder here, right? So again, we have the periodic table, we have alkaline metals, alkaline earth metals, transition metals, halogens, noble gases. If I zoom in a little bit on parts of the periodic table, certain elements carry certain charges. If you remember in the middle of the periodic table right here with the transition metals form multiple charges. And then elements in group 1 right here, like hydrogen, lithium, sodium, they form +1 charge. We've got group 2. They form a +2 charge, BeMgCa. Group 3 is right here. They form a +3 charge. Group 4 we haven't talked too much about, but it could be +4 or -4. Then we get to group 5, and those elements form a charge of -3. Group 6 form a charge of -2. Group 7 form a charge of -1. And this is group 8. They don't really form charges. They are known as noble gases. They don't really form charges. And so just a little refresher there. And so these elements can combine either in ions or atoms to form compounds. And so just again, another refresher here. We have simple binary ionic compounds, which is a metal and a nonmetal. So something like Na and F. Na is a +1 charge. F is a -1 charge. If you remember from our previous unit, I could do a little crisscross method and I could get NaF as the compound. Aluminum forms a +3 charge. It's in group 3. Bromine forms a -1 charge. It's in group 7. I could do the crisscross method again, and I get AlBr3. Just a little refresher there. Transition ionic compounds, I'll need more information. Fe is a transition metal, so Fe is iron. It's a transition metal. It could form multiple charges, like Fe+1 or Fe+2. So it could form different compounds with F, so like FeF or FeF2 as an example. Same thing with copper. Copper is a transition metal. Cu is copper. It could form +1. It could form +2. I could have compounds like CuCl, CuCl2. Just putting some examples there. And then finally, the last thing we had learned in that unit were molecular compounds. Those are two nonmetals, nonmetal and nonmetal. Again, the nonmetals are found on the far right-hand portion of the periodic table. So N and O could form multiple different compounds. It could form NO2. It could do N2O5. Or S and Cl. Two nonmetals could form multiple compounds. SCl4. I could get S3Cl7, and that's two nonmetals to give me a molecular compound. So a crash course. Now, these compounds didn't just exist, they reacted. And although we haven't focused on it, these compounds are formulas that have a certain ratio of atoms. And when I say ratio, a little math term, that's a fraction. So like a ratio could be 1/2 or 2:1. Just throwing that out there. And these ratios are experimentally determined, and you're going to be able to get into the lab and do an experiment to determine the ratio of atoms in a compound that forms. So for example, if I had 10 grams of lead is a transition metal, its symbol is Pb, and I reacted it with 1.56 grams of sulfur, that's S, I'll get lead sulfide. And what we could experimentally determine is that this would require one atom of lead, one Pb atom, combining with two S atoms, so let's say this is one Pb atom, combining with two S atoms to give me PbS2. And I could draw that. Now, before we get into the lab, I want to make sure that we could count atoms in formulas, count atoms and ions. So let's go back to some of the compounds and ionic compounds that we had earlier. So look at NaF. There is one Na ion and one F ion in this compound. There's two ions total. When we did AlBr3, there's one Al3 plus ion and 3 Br ion, which gives us a total of 4 ions total. And again, just if we forgot what an ion is vocabulary, they are charged particles. We could do that for FeF2. There's one Fe2 plus and two Fe minus 1 ions. Altogether, 1 plus 2, there are 3 ions total. If I had a compound like FeF3, that's 1 Fe3 plus. Look, it could have a different charge because it's a transition metal. And there are 3 F minus ions. 3 plus 1, those are 4 ions total. I already did CuCl2. There's one Cu2 plus ion and 2 Cl ions to give me a total of 3 ions. Look at CuCl. There's no subscripts here. With no subscripts, we assume it's just one. Like, here's the formula for water. If I don't have a subscript, we assume it's 1. And so this means I have 1 copper plus ion and 1 Cl minus ion. 1 plus 1, I have 2 ions total. And that's a little vocabulary. If I have an ionic compound, I could count the ratios, or I could count the different number of each of them, and it becomes a different number of ions. But if I have molecular compounds like over here, we use the word atoms, which we know that word atom from a previous unit. N2O5, look at the little subscript, there are 2 N atoms and 5 O atoms. That's a total of 2 plus 5 is 7 atoms. We could do S3Cl7. There are 3 S atoms and 7 Cl atoms. 7 plus 3, that's 10 atoms total. For NO2, there's one N atom and 2 O atoms. 1 plus 2, 3 atoms total. I also did S4Cl6 right here in the notes for you. 4 S atoms, 6 Cl atoms. 6 plus 4 gives me 10 atoms. We're going to end this video here. I'd like you to do the examples here to make sure that you could look at formulas and count the total number of atoms in each formula. We're going to do number 1 together so you know how to do 2, 3, and 4. For number 1, I'd like you to identify the number of each type of ion or atom and the total number of ions atoms. P2O3, these are 2 nonmetals. So this is going to be my atoms business. There are 2 P atoms, 3 O atoms. So in total, there are 5 atoms. I'm going to help you out for number 2. These are going to have the term ions. For 3, you're going to use atoms because it's an ionic compound. This is molecular. And for number 4, you're also going to have the word atoms because this is also going to be